This is my weekly video log for Sprint 1. Our assignment for this week was to get the mushroom grid working as well as centipede movement, and then optionally we had to choose between shooting the mushrooms with the blaster and or having the blaster collide with the mushrooms and not be able to pass through them. So I've got blaster movement working. Everything is locked to the correct spaces. You can't walk out. You can't walk outside of the visible screen. You also can't collide or can't pass through the mushrooms, and you slide off the mushrooms properly, which is something I'm a little bit proud of because this was a little bit of a pain in the ass to get working. It shouldn't have been, but it was. And since I'm an overachiever, I also did. Yay! Mushroom shootiness works. So the first interesting implementation note that I have about how I got this working was that bullet that the blaster shoots. When it is locked to the blaster and when it is flying through the air, that is the same bullet. I do not destroy and recreate bullets. I just have it actually physically move itself around with the blaster. And then when it's on the blaster, it deregisters itself from collisions. So I can do stuff like this, rub up against the mushrooms, and the bullet doesn't actually destroy the mushrooms for you. That's that. Now, in terms of interesting implementation details, the other thing that I think is worth noting is I decided to go with this base grid object class, which primarily serves the purpose of converting grid space coordinates to world space coordinates, because world space coordinates are actually in pixels. And I didn't want to have to manually run that conversion every time I needed to move something around or set something's position. So I wrapped everything up within this grid object class, and now I've got, every time I want to set the position of an object or translate an object, I can pass in those values in grid space coordinates. It'll do the conversion, the times 16 multiplication, and pop them out in world space coordinates. This also has the advantage of giving me a little bit more state to my game objects. In a lot of the engines I'm used to working with, primarily Unity, game objects themselves house the game that transform. In this case, just the position and rotation of the game object. So if you want to say make your object spin around, you spin the game object around. In Teal, game objects don't have any sense of position. They only have only the animated sprites do. So when you're moving your game object around, you're actually moving the sprite around, and then collisions are run based on that sprite and where it appears in the world, because it's very much just a 2D engine. Since that interface wasn't super natural to me, I decided to wrap it up in this position, or wrap it up in the grid object base class by giving it a position private member that you can set through set position translate. And there's actually no way to get the position at this point, but I think that's just because I didn't need it at all for this sprint. But the position itself is stored in grid space. So this is just storing whatever the latest position is. And then the conversion to actual Teal world space is only done when moving around this main sprite, which I think is a system that works pretty well and gives me a little bit of a nicer interface when interacting with my game objects. That is it as far as funky stuff for Sprint 1. Otherwise, I got everything done, and I'm not behind yet. So that is it for this week.